afternoon friends, and in this video we are going to solve some more questions based on the implicit functions or the implicit equations, and this time we will be taking some very good equations and try to find out their derivatives. So here we go, and then if you have any problems, like if you have any specific problems if you want to ask, then please type that questions in our comment section, and then in the next video we'll try to accommodate that questions in our videos. So now here I have taken some of the questions. One question goes like, if sine y equals x sine a plus y equals x sine a plus y, then show that dy by dx, this is dy by dx is sine square a plus y upon sine a. So now I start from here. So we'll start writing differentiating both sides with respect to x. Then sine y will become cos y, and then dy by dx. This is x sine a plus y, means this is product of two functions. This is u and this is your v. So the rule says that first I have to keep x unchanged, then differentiation of sine a plus y plus, next time you keep sine a plus y constant and differentiate x. So this is x, sine a plus y differentiation is cos a plus y, and then we have to find differentiation of this a plus y. As I discussed in the last video, like d by dx of sine something is the cos something, and differentiation. Okay, so x dy by dx this plus sine a plus y d by dx of x. Now x and d by dx of sine a plus y is cos a plus y, and the differentiation of a plus y. So a is constant, so differentiation of constant is 0, and the differentiation of y is dy by dx. So 0 plus dy by dx will be just dy by dx, plus this is sine a plus y. Since we have to find dy by dx, and we have dy by dx here and there, one is here, other is there, so I'll just try to keep this one on this side. So we have cos y minus x cos a plus y dy by dx equals sine a plus y. Now here see, when we are trying to find the answer of dy by dx, then we are getting cos y and this cos here, but we don't have any cos here. It means there needs to be some substitution, and there it is. So you see, what is x? X is sine y over sine a plus y. So this is x is sine y over sine a plus y. This is cos y minus, and this is cos a plus y dy by dx, and this is sine a plus y. Now here you see we have cos y. Now if you take the LCM, then this will become sine, is it okay? Do you see properly? Sine a plus y cos y minus sine y cos a plus y whole upon sine a plus y dy by dx equals sine a plus y. So now here you see the form sin A cos B minus cos A sin B. So this will become sin A minus B. So we will have sin A plus y minus y upon sin A plus y dy over dx equals sin A plus y. So this y cancel, you have sin A and I put this on this side. So dy by dx equal to this sin A plus y goes here and multiplies. So this will become sin square A plus y, and this sin y, it will come down and this will become sin A. This is your answer. So now just let me clear the screen and then I'll take one more better example. Okay, now this time we have equation of this specific order which goes like y equals under root x plus under root x plus under root x plus under root x plus dot 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 till infinity. And then what we have to find out, 2x minus 1 dy by dx, 2x minus 1 dy by dx equals 1. So now see, y equals to under root x plus under root x plus under root x plus under root x plus, keep on happening till infinity. So infinity is such a big term that if you take one term out of this, then that will not be any, that will not make any difference in this value of this infinite sequence. So I mean to say that if this term, what is this term? If you see properly, what is this term? This term is also y, because this is root x plus root x plus root x plus root x, like that. Then we can write y equals under root x plus y, because this term is just y. So now squaring both sides, we have y square is x plus y. Now differentiating both sides with respect to x. So differentiation of y square will be 2y dy over dx. Differentiation of x is 1, thus differentiation of y is dy by dx. Then take this dy by dx on this side and make it common. So dy by dx will become 2y minus 1 is 1. Then dy over dx is 1 over, this is so we are getting 2y minus 1, and this is also y, it's not x, it was a mistake there. So now if you cross multiply, you will find these two terms are same. Now I need to take one more example, so let me clear my screen. We have, if y equals 1 over x plus 1 over x plus 1 over x plus 1 over x plus dot 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 infinity. Then dy by dx is y over 2y minus x, y over 2y minus x dy by dx. This is what we have to show that. Show that dy by dx is y over 2y minus x. Now you see this is 1 over x plus. So now just try to understand this one. 1 over x plus 1 over x plus 1 over x plus. Now what was y? 1 over x plus 1 over x plus. So it means whatever I have put in the box, that is also y. So we have y is 1 over x plus y. Now cross multiply, xy plus y square equal to 1. Differentiating both sides with respect to x, Now this is UV rule because x into y, product of two functions. So x into differentiation of y, that is dy by dx, plus y into differentiation of x, that is 1, plus differentiation of y square, that is 2y, dy over dx, and differentiation of constant is 0. So you take x plus 2y dy by dx plus y equals 0. Then dy by dx is y over. Again I have to verify whether this one is proper or not. So this one looks wrong. This is y over 2y minus x and we are getting 2y plus x. So either we are wrong or either the question is wrong. Now let me see, because we have x plus, so this is x plus y is correct. So you are getting plus only, so this is plus, so it means the answer will be minus y over, the answer should be like this. So here we have dy by dx is minus y over x plus 2y. This is what the answer is. So this is all about this question. Now I'll take one more question to explain the thing. So now I have another question which goes like this. If y under root 1 minus x square plus x under root 1 minus y square, then dy by dx equals under root 1 minus y square over 1 minus y square over 1 minus x square. Now this one is little tricky, because if you go and find it, suppose if I just go in a random way, I'll go. So I write differentiating both sides. One thing you have to remember, that this is the formula, that e by dx of under root x is 1 by 2 under root x. This is the formula because I'll be using it directly. So differentiating both sides with respect to x. So this is uv, this is also uv, and if y equal to this, and there should be some equal to on this side, this is 1. So now here I go, so I write y unchanged, differentiation of this 1 upon 2 under root 1 minus x square into differentiation of what is in between the root, that is 1 minus x square, so that is 0, and then it is minus 2x. Done. So root x, differentiation of root x is 1 upon 2 root x, and differentiation of root something is 1 upon 2 root something into differentiation of that something. So differentiation of root 1 minus x square is 1 over 2 under root something, that is 1 minus x square, and differentiation of this something, that is 1 minus x square, is 0 minus 2x, that is minus 2x, plus keep under root 1 minus x square constant and then differentiate y. This will give you dy by dx plus second part. Now x into differentiation of this, again very same order, but we have the function under root 1 minus y square and we are differentiating with respect to x. So I will get the answer in terms of y, and then I simply attach dy by dx beside it. So x into 1 upon 2 under root 1 minus y square, this is minus 2y dy by dx, plus now under root 1 minus y square unchanged, and differentiation of this x is 1 and differentiation of this constant is 0. So we have got these four terms. Now I'll keep the dy by dx terms together and try to find out what better we can do. So here this part you can see 2 cancel 2, 2 cancel 2, this is minus. So minus xy over under root 1 minus x square, plus again it is minus xy over under root 1 minus y square, and this term and then this term. and here we have dy by dx, plus I write this term under root 1 minus x square dy by dx plus under root 1 minus y square equal to 0. So now we have two terms having dy by dx and two terms without dy by dx. So I do these dy, first I take dy by dx common, dy by dx, this is positive and this is negative, so I am getting under root 1 minus x square minus xy upon under root 1 minus y square equals, I take this on the other side, so this will become positive and this will become negative. So it is xy upon under root 1 minus x square minus under root 1 minus y square. So now here you see that we have this relation. So under root 1 minus x under root 1 minus this one. So now even if you do whatever, you cannot find the answer coming right away like this, because it looking very weird. But let me continue. So this dy by dx multiply, then become under root 1 minus x square 1 minus y square minus xy upon under root 1 minus y square, and here this will become xy minus under root 1 minus y square 1 minus x square. So here I put these three things together because root a into root b is root a minus b. Here also let me do the same thing. So they are in the same root upon whole upon under root 1 minus x square. Now I think we are close. This term, this minus under root 1 minus x square under root 1 minus y square minus xy, and this is xy minus. So these two are same, only the negative one. Just like if this is a minus b, this is b minus a. So if you cancel them, you will get y. So let me write the term here. So dy by dx equal to, I cut this and this, then I write just minus. So here this one will go up. So under root 1 minus y square upon under root 1 minus x square. So we have everything proper, only there is sign difference we are feeling. Now let me check it out again. This is y times minus this, fine, plus, fine. This is x, this is minus, fine, this is fine. So this one should be negative, this one should be positive, this there. This one should be negative, there. This one should be positive, it is there. So if I keep the dy by dx things together here, then I am getting this term positive, and then minus xy over this, fine, and this term, this one will goes on this side, become positive, xy over 1 minus x square minus this one, fine. So dy by dx, this into this minus 1 upon this, and here it is this minus this upon this is this. So yes, in the question also, yes, there is a negative, sorry, my bad, there is a negative, and here also we have got the negative, so it is correct. But this approach is, you need to be very sharp into this, otherwise you will get confused. Now I have another method of solving the same question but in a different way. So first let me clear the screen. Till now you can hold the screen and you can keep writing about this in the question. Now if I use method of substitution, so see 1 minus x square, this is just giving me idea, because I know that 1 minus sine square theta is cos square theta and 1 minus cos square theta is sine theta. So in the same line, if I write x equal to sine theta and y equal to sine alpha, then what will happen? Then this y will become sine alpha under root 1 minus x square. So 1 minus sine square theta will become, this is cos square theta, plus x, which is sine theta, and then under root 1 minus y square, which is sine square alpha, is cos square alpha is 1. So now the root is gone, so you'll have sine alpha cos theta plus cos alpha sine theta equals 1. So this one gives you the formula that sine alpha plus theta equal to 1. Now therefore alpha plus theta equal to pi by 2. So this is alpha plus theta is pi by 2. So you are getting the final answer as x alpha plus theta is pi by 2. Now what is alpha? Alpha is sine inverse y. So this is sine inverse y, and what is theta? Sine inverse x. So sine inverse x equal to pi by 2. Now if you differentiate, then sine inverse y's differentiation is 1 over under root 1 minus y square dy by dx, because we are differentiating with respect to x and this is function of y, plus this is 1 upon under root 1 minus x square, and differentiation of this is 0. So dy by dx equals minus 1 upon under root 1 minus x square into under root 1 minus y square upon 1 is minus under root 1 minus y square upon under root 1 minus dy by dx. So this is this. Now you see how easily I got this answer rather than I used a very complicated, and it was not complicated, but everyone is not good at it initially. But if you keep practicing, then with hard work, sincerity and perseverance, you can also achieve a smartness, a great skill of manipulating these algebraical terms, and then it is not much difference. But you need some sacrifices, like you have to concentrate, you have to be punctual, you have to keep on practicing most of the times, and very importantly, you should have the attitude never give up. Thank you very much. Just subscribe to our channel and keep growing with us.